Let's make a histogram in Excel. Now we can see the data, sample data for this histogram. The length of the steel bars in mm as given in this column is the sample data from which we will make the histogram. As you can see, there are 100 observations taken from this process. Now histogram is used to make, as we know, to find out the frequency distribution of the data. So we need to find out how this data is distributed. So in the x-axis we will have the intervals, and in the y-axis we will have the frequency or the count for that each interval. So before you begin the histogram, we need to decide the number of intervals and the size of each interval. So as we can see, there are 100 observations. We know a formula for number of intervals approximately equal to the square root of number of observations. So we can say the square root of 100 observations, which is equal to 10. So we can have around 10 intervals. This is not a hard and fast rule, but it gives us an approximate number. Now we also need to decide the size of each interval. For that, we first want to know how much the data is spread. So let's find out the maximum of this data. So you can use the maximum formula of, of Excel, and let's find out the maximum value, and similarly let's find the minimum value. For this sample data. So we can see the values range from 250.25 mm to 259.50 mm. So let's see the difference between the maximum and the minimum, which is also called as the range. So difference is approximately 10, and we know the number of intervals, we will keep it as 10. So let's say the size of each interval equal to 1 mm, because the range of the values is around 9.25, so it's around 10 mm, and we know we want around 10 observations. So obviously 10 divided by 10, the size of each interval will be 1 mm. And remember that the x-axis value should be continuous in the ascending order. Why it is called continuous? Because we don't want to miss any values out of these 100 values. So the interval will be from 250, let's say, to 260. So it will include all the values and we will not miss any values. So let's make the table. Let's say serial number and interval, frequency, also called as the count. So we have around 10 values. So let's decide the interval. As we know, we will start from 250 mm to, and the size of each interval is 1 mm. So let's say 250 1 mm, right? Remember, continuous data means we don't want to miss any values. So the next data will be 251 to 252 mm and so on. So we have the 10 intervals and we want to count the values in each interval or the frequency. So let's use an Excel formula for counting the values. Now the Excel formula is count if. Now there are two formulas, count if and count if s. We need count if s because we are going to have two criteria. One is that the value should be greater than 250 mm and it should also be less than 251 mm. So we have two criteria. So that is the reason we will use count if s. So the formula for this is count if s, and we have to give the range of the criteria. So it is from 1 to 100 all the observations, and then we have to provide the criteria. It should be in double quotes, uh, greater than 250, close the double quotes. Then we have to provide the next criteria and the range for the next criteria, which will be same. The range will be the same for the second criteria. The value should be less than 251 mm. So the formula is the range and the criteria, first criteria, which is the values to be greater than 250 mm, then the same range, and the value should be less than 251 mm, so that it will count all the values greater than 250 mm and less than 251 mm for this range. Press enter. So it is counted as 1. So let's copy the formula for the other cells. Let's press F4 because the range is same. All right, and for the second row the criteria will change to greater than 251 and less than 252, and for the third row greater than 252 and less than 253, and so on. So it has counted 16 values in this interval. So all the values have been counted in these intervals. Imagine if you were to count it manually, it will take you a lot of time, and instead of 100 values you have 200 or 300 values. Imagine how much time it will take. So the formula for from Excel is very handy. Now let's make a total, and we have 100 total observations, which is matching the 100 values in this column, so it is okay. Now we have the data to make the histogram chart. So let's select these two data, the interval and the frequency, and let's insert the chart. Go to insert, recommended chart, and we want a histogram. So go to all charts, go to columns, and we want the clustered column, then insert. So we have the chart, and we can change the title to histogram frequency distribution of length of steel bar. So it shows the intervals and the frequency or the count of values in each interval. So let's have a different design, and remember that uh, the histogram is prepared with no gap between the values, because the values of histogram, as you can see here, it's continuous. So the traditionally the values, the bars are close to each other. So let us reduce the gap between the bars. So click on those bars and reduce the gap with, make it 0, or let's say 2%. So this is how the frequency distribution is prepared. We can analyze the distribution, and we can analyze the process and make some changes so that the distribution is uniform on the right hand side of the graph. It is a unimodal histogram, and we can see the spread of the distribution is uh, spread across a lot of values which are greater than 255 mm. So the problem may lie here in this part of the process. So this is how the frequency distribution is prepared, or the histogram is prepared. We can change the y-axis units. We have the major units as 5. We can make it 2 if we want, or even 1, and so on. We can remove the grid lines. So this is about the histogram. In the next lecture we will start with a new QC tool.